I'm Dr. Rajesh Khanna, Department of IT, We'll take Multitech, Dr. Rangaraj and Dr. Sugandhara Engineering College. Today, we'll discuss about the Internet of Things, IoT. So, first of all, what is IoT? Can this is very in order before saying about IoT, I need to know, and you people need to know the fundamentals of Internet of Things, and need to learn about the basics of IoT protocols, and you need to build a small low cost embedded system using Raspberry Pi, and need to apply the concept of uh, Internet of Things in the real world scenario. So this is what in the cases. What is IoT? So it is another Internet of Things. It refer to the um, interconnection of the physical devices such as home appliances and vehicles that actually embedded with the softwares and sensors and connectivity, which enable these objects to connect and exchange data. So that is what an IoT. Okay, this technology actually in the IoT technology, it allows for the collection and share the data from the vast network of devices, creating the opportunities for more efficient and automated system. So this is what an IoT. This connect the unconnected. So this is what an uh, Internet of Things. So Internet technology, the connecting devices and machines and tools to the Internet through the wireless technologies. So as of now, over the 9 billion things are connected to the Internet. Soon the things can be connected to the Internet will cross the 20 billions. So the technologies such as low power embedded system, cloud computing, big data, machine learning, and networking, which are the most very relevant to this particular IoT. So, so between the years of 2008 to 2009, a number of things are connected to the internet, to the world today. And now we are seeing the gaming systems was in 1999. It assigned the new idea related to the linking the company relevant to the supply chain management, okay, to the internet. So this is what an IoT is a major technology to shift to this one. Okay. So this is what an evaluation of IoT. As a usually we will compare with the intelligent connection with the business and societal impact. So first we did the connectivity, mostly the digitize the access for the email, web browser and search. And then we move on to the network economic for digitize the business relevant to the e-commerce and digital supply chain and collaboration purpose, we just move on to that. And we are just, again, we move on to the immersive experience for social and mobility and cloud and video categories. So this is a digitized interactions we made them reward an evaluation of IoT. Now IoT is the Internet of Things, which digitize the world by connecting the people, process, data, and things. So this is what an evaluationary phases of the internet. So we have the connectivities and the network economics and immersive experience and the Internet of Things. This Internet of Things is adding the connectivity to the object and machine in the world around us to enable the new services and experience. It is a connecting the unconnected. It is very important. It is a connecting the unconnected. So actually, the IoT is a network of the physical object that connect the electronics embedded to their architecture in order to communicate and say and sense the interaction among each other with respect to the external environment. Okay, in the upcoming years, most of the IoT-based technologies will offer the advanced level of services, and also the practical changes can be happen in the particular in this environment. For I mean, for example, in order to detect the objects like animals and people, that are each and every object will have provided the unique identifier. So with the help of for example, a number of things can be added in this particular Internet of Things category. And then the naming can be very complicated. So we are just Actually the system of internet. I mean, interesting thing is we need to compute the devices, and we need to make and non mechanical and as well as the digital needs to be there. And for example, if I mean the object and animals or people, that are provided with the unique identifiers. So the ability to transfer the data over the network requiring here is human to human or human to computer interactions. So if we discuss about the IoTs from the 1982, the first the vending machines came, and for the first glimpse of the IoT emerged as a vending machine at the Carnegie Mellon University was connected to the internet to report his inventory and status. So IoT and digitization. So what is that? It is a connecting the things. Object and machines are connected to the computer network to internet. What about the digitization? It is a connection of things. Focus on the data generated by the devices and the business insights at result. So, what are the characteristics of IoT? I mean, before telling something about the characteristics of the IoT, we need to know about the components of IoT. What is component? The device or sensor is also the one of the component of Internet of Things, and connectivity is also the component, and data processing also the one of the component of the IoT. And main one is interfaces. It is a main one of the and component of the IoT. So the characteristic means we can able to dynamically adapt with the changing context and take the action based on the operating conditions. For example, if we can surveil the cameras and it can be adapt the model based on whether it is day or night. So you can also say configuring the IoT devices. We need to monitor the overall smart city or smart home. In that cases, a large number of devices to work together to provide us certain functionalities. And another characteristics of IoT is it is an interoperable communication protocol. So it does not depend on the same particular protocol. Different protocols can be communicated. For example, we can use the HTTP protocol and FTP protocols. So IoT devices may support a number of interoperable communication protocol. It can communicate with the other devices and also with the infrastructures. So and the next important characteristics of IoT is unique identity. Each IoT devices has a unique identity and unique identifier. What I mean is it is an IP address, right? And we can also integrate into the information networks. With the help of IoT devices are usually integrated to the information networks that allow them to communicate and exchange the data with other devices and systems. So actually, the physical design of the IoT is the things. What I mean is, an IoT usually refers to the IoT device which has the unique identities and can perform the remote sensing, act- actuating, and monitoring the capabilities. Okay, the IoT devices can exchange the data and collect the data from the other devices and process the data locally, or we can also send the data to the centralized servers or cloud-based application, the backend for the processing the data. So usually we need a cloud. Okay, we need actually this is actually the IoT is a technology to communicate between the devices and cloud. And not only this, it also between the devices themselves can connect it. So that is what an IoT. It performs some tasks locally and other tasks within the IoT infrastructures based on the temporal and space constraints. So this is the physical design of the IoT. There is a generic block diagram of the IoT devices. We have the connectivity and processor, and audio and video interfaces, and I/O interfaces. So usually the I/O interfaces for the sensors and actuators we use this one. So we have the memory interfaces and graphics and storage interfaces also there. So actually, the IoT devices may consist of several interfaces for what means for connection to the other devices, both wired and wireless. So I/O interfaces for sensor and interfaces for internet connectivity. And memory and storage interfaces are also available, and we also have the audio and video interfaces are also available in the IoT. This is what in a physical design. We have the link layer, network internet layer, transport layer, and application layer. So this is what is the protocol. So whenever we want to exchange the data and share the data, so we need to follow some protocol also. So usually in the transport layer we use the TCP and UDP protocol. So this is what a logical design of the IoT. As actually, the logical design of the IoT refers to the abstract representation of the entities and the low level specifies of the implementation. So this is what in the functional block that provide a system of the capability and for identification, sensing, and actuation, and communication and management. So the logical design of the IoT devices, it provides sensing and actuation and monitoring and control the functions. And next one is communication. It handles the communication system and service. Here the various types of IoT services are there, such as service for device monitoring, device control services, data publishing services, the services for service discoveries, and we have the management. This is function block which provide the various functions to govern the IoT system. In the function block, in the main one is the security. Provide a function such as application authorization message and content integrity and data security. And another important function block of the IoT is the application. This is where it provides an interface that user can use to control and monitor the various aspects of the IoT system, right? So the main component, if you think about the IoT is low power embedded system, is a less battery consumption, high performance, or the inverse factor that plays a significant, I mean, significant. I mean, what I mean is, it is an that plays in a significant role during the design of the electronic systems. Sensor, which is a major part of the any IoT specific application. So it is a physical device that measure and detect the certain physical quality and quantities and convert it into the signals which can be provided as an input to processing or controlling the unit for analysis purpose. So we have the different types of sensors are there. For agriculture purpose and for infrastructure purpose and commercial purpose and n number of areas that this type of IoTs are they are utilizing, they are using. Based on that, the sensors also will be different types of sensors they are using. For example, temperature sensor. We have the image sensors are there, and then obstacle sensor, the RF sensor, IR sensor, and gas sensors are there. Ultrasonic distance sensors are there. So here we have the control units. Okay, it is actually the control unit means it is a unit of small computer on a single integrated circuit containing the microprocessor or processing core will be there. And not only that, we also have the memory and programmable input and output devices or peripherals also available. It is responsible for what? For major processing the work of IoT devices, and all logical operations can be carried out here in the control unit. The next is cloud computing. What is cloud computing? I say it is a data collected through the IoT devices or massive. It is a large data. We need to store the data in the reliable storage server. So this is where the cloud computing comes to the day. I mean comes into the play. The data is processed and learned and giving more room for us to discover what things like electrical fault or error or within the systems we can identify with the help of storing all the details then and there, anytime, anywhere. I mean, the connectivity is be, connectivity will be there. So we need not to worry about uh, data, storing or sharing purpose. We can need not to worry about it. So we can connect with that. We can able to access or we can able to get it from that. Okay. The ways of building of there's two ways of buildings. If you want to build IoT, uh, we need to form a separate internet work. including any physical device. I mean, include only the physical device, any not only physical device, and make the internet ever more expensive. But this requires a hardcore technology. So need a cloud computing and rapid big storage uh, is very expensive one. So the IoT enabling technologies are wireless sensor network, cloud computing, or what I made it before, cloud computing, uh, and then big data analytics and communication protocol and embedded system. So the WSN is comprises the distributed devices sensor which are used to monitor the environmental and physical conditions. Actually, this consists of end node, router, and coordinator. The end node has several sensors attached to them. The data is passed to the coordinator with the help of routers. The coordinator acts as a gateway in order to connect the wireless sensor network to the internet. Say, for example, if you nowadays we are monitoring the weather monitoring systems are there. You know to know today the time will be come or not. We can able to predict before itself. And indoor air quality monitoring systems are there. And soil moisture monitoring systems are there. Surveillance systems are there. The cloud is it provides a means by which we can access the application as a utility over the internet. So we are just going to store all the data. We can access the data anywhere like a database or web server and storage or any devices, any software over the internet. So the cloud computing of important characteristics is it is we can pay per use, we can measure the service, it is an on-demand self-service. We have the broad network access, so no issue whether the available data are can be able to uh, uh, access at any time or not. Because the cloud, with the help of cloud, I can able to access the data anytime, anywhere, any place. It provides different types of services, infrastructure as a service, platform as a service, and software as a service. So based on your requirement, we can use this type of service. For example, if you need to provide online services such as a physical machine, a virtual machine, servers, and networking storage, data center spaces, on pay-per-use basis, you can use it. Okay, for example, the major IaaS providers are Google Computing Engines, Amazon Web Service, and Microsoft Azure are there. So, for example, if you want to web, we need to host a web or virtual machines, so you can use this type of IaaS. So, platform as a service, it provides a cloud-based environment, very things required to support complete life cycle of building and delivering the cloud application without the cost and complexity of buying and managing the underlying hardware and software provisioning and hosting. Right. For example, is the Google App Engines. Okay. Now is the big data analytics. What is big data analytics? Here it refers to the method studying the massive volume of the data or being data. So, for example, in sensor, we will collect the n number of data. The collection of data whose volume and velocity varieties is simply too massive and tough to store and control and process and examine the data using the traditional database. So, for that purpose only, we just move on to the big data. Big data is actually the gathered from the variety of sources, including the social network videos, digital images, and sensor and sales transaction reports. So we need to first of all we need to whatever collected the data, we need to data cleaning process to be done, visualizations to be done. And example for this big data analytics, we can bank transactions is a good example for this particular big data analytics. Even the data generated by the IoT system for location and tracking of the vehicle e-commerce, and health and fitness data generated by the IoT system such as a fitness band. So actually, in order to make the IoT enable us, RFIDs are the sensors are the nanotechnology, we have the smart networks are the, for example, mesh topologies. So the working with IoT devices is we need to collect and transmit the data. For this purpose, the sensors are widely used. They are used as a for the requirement in different application area, and then we need to activate the actuate the devices based on the trigger produced by the sensor processing the devices, and we need to receive the information and we need to communication assistance. The communication assistance means it is a phenomenon of communication between the two networks, or communication between the two or more IoT devices of the same or different networks. So the communication protocol is the backbone of the IoT system. It enables the network connectivity and linking to the application. The communication protocols allow the devices to exchange the data over the network. And not I'm talking about the same network. It is a different network also. You can able to change it. I mean, you can exchange data. For example, the different communication protocol means what I mean is we have the constraint application protocol, Zigbee or the FTP and HTTP. So like that, there are so many protocols are there. So the group of protocols are designed to work together is known as the protocol suite. When implemented in software, we have the protocol stack. They are used in data encoding and addressing schemes in the main as the embedded system. Okay, this is what in a case. It is actually why they mean as the embedded system means it is a combination of hardware and software used to uh, perform the special task. It includes the microcontroller and microprocessor, memory, networking units, Ethernet Wi-Fi adapters, and input and output units for display keywords and storage devices, flash memory. It collects the data and sends it to the internet. The embedded system is used in a digital camera, industrial robot, DVD player, music player, and the wireless routers also embedded systems are. The IoT level and deployment temperature. First, we need the database. The database can be either local or in the cloud and store the data generated by you, whatever the IoT devices, the data are generated, so everything will be stored in the database. And we need a web service in order to serve the link between the IoT devices and application and database and analysis component. We need the web service. For that purpose, we need HTTP and REST principles. And also, we can also use the WebSocket protocol. And we need to analyze the component. For that purpose, we need to analyze the IoT data, right? And we need to generate the result for that. And from that, we can able to easily you can able to understand what is data actually, right? The next IoT level is application. So it provides an interface that user can use to control and you can monitor the various aspects of the IoT system. So that's all about today's session. Thank you.